Hello guys, welcome back to my channel. So today we'll be solving question number 8 and 9 of 5070 paper 2 variant 2 October November 2023. So let's begin with the question. Okay, question number 8 part A. The equation for the reaction of carbon monoxide with hydrogen at a high temperature in a closed container is shown. Okay, the forward reaction is observed. Let me highlight this. Okay, part 1, predict and explain the effect, if any, on the position of equilibrium when the pressure is increased and the temperature remains constant. All right. So, while answering such questions, their pressure is varied, whether increased or decreased. We have to look that in the given equation, we have to just look at the gases only, not the solids or liquids. So here in this equation, we have we have our gases, so we don't have to worry about the solid. Okay, so here hydrogen is 2 moles and carbon monoxide is 1 mole, so total will be 3 moles. And at the reactant side, methanol is 1 mole, so total 3 moles at the reactant side and 1 mole at the product side. So 3:1 ratio is present. Here the pressure is being increased. The pressure is increased. And we know that when the pressure is increased, the equilibrium moves towards the side with lesser moles. So we know that at the product side there are lesser moles. So we'll write position of equilibrium move towards right, moves to the right. Cause uh, I should write, it's related to the product, so I should write like few. I could write either like there are more moles on the reactant side, or I could write there are fewer moles. I just fewer moles at the product side or at the right side. I've used right hand, the same. The right. Side. Okay. Part 2. Predict and explain the effect of any on the position of equilibrium when the temperature is increased and the pressure remains constant. All right. So here the temperature is being varied. So look at the piece of information I had highlighted earlier. It tells us that the forward reaction is exothermic, which means this is exothermic, and the backward reaction would be obviously endothermic. All right. So we know that when the temperature is increased, the equilibrium move towards the endothermic side. Why? This is because to nullify the effect of increasing temperature. Okay, so let me write it here to predict and explain. So I would write that position of equilibrium moves to the left, because forward reaction is exothermic. All right. Okay, so part B, methanol reacts with ethanoic acid. Here is the formula of ethanoic acid. Okay, and sorry, to produce an ester. Okay, name the ester and draw its displayed formula. First, I would suggest you to draw the displayed formula. So, naming the ester would be pretty easier. And here I will just show how the ester would form. All right, ethanol. First, I guess I should draw ethanoic acid. So, all right. We don't need to draw methanol or ethanoic acid. We need to draw the product, which is the ester. But I'm drawing it just to explain it to you how the mechanism works. Okay. Okay. So it's CH3OH. Yeah. So H from the alcohol and OH from carboxylic would be removed to form water. And we need to, in A levels, you will learn it that while during the process of esterification, OH is being removed from the acid and H is being removed from the alcohol. So, all right. So after the removal, so water is removed. Let me highlight it. Okay. And it can be any of the H which is attached to the carbon. Okay, or not even carbon. Sorry, not carbon. I'm really very sorry. It would be from OH. Let me draw it like this. It's could be like so. It's not shifted. Let me draw it again. Okay, so like this. Okay, so the product would be CH. The initial part of the ester is from the carboxylic acid, C double bond O, and O, C, H. So basically, this part comes from the acid, carboxylic acid, and this part comes from the alcohol. Okay, and basically This is the ester linkage. All right, I'll remove these two reactants as all we only need the product. Okay, so I'll place it here. And now after drawing the displayed formula, we can easily name the ester. And while naming it, you should remember that the last part is written first and the initial part is written at in the last. So what it would be? Here we have one carbon. Here we have one carbon. And okay, so how to, let me tell you one thing, that how to know which is where the last part starts and where the first part ends. So basically this at this point where O, singly bonded O, you see the singly bonded O. So the carbons before it will be the last part, and the carbon after it would be the sorry, the carbon before it would be the part of carboxylic acid and would be written in the last while naming, and the carbon after the O, singly bonded O, will are the part of alcohol, and they would be named they would be written first while naming. Okay, so here we have one carbon, so I would write it methyl, and I have two carbons after the singly bonded O, sorry, before the singly bonded O, so I would write it ethanoid. Okay, perfect. Let's move towards the next question. Part C, methanol is a member of the alcohol homologous series. Describe two general characteristics of a homologous series. Firstly, I would write they have the same general formula. And then I would write they have the same functional group. Okay. And let's move towards question number 9. Table 9.1 shows the melting points and relative electrical conductivities of three elements. Right. Here is the table 9.1. Okay. Use ideas about structure and bonding to explain. Okay. Part 1. The difference in the melting point of diamond and iodine. Okay. Let's look at them. Here is diamond and here is iodine, and the melting points are here. So, sorry. So, these two, 3550 and 114. Okay. So, the question is of, let's see, 3 marks. Okay. So, we need to explain the difference in the melting points. Okay. So, basically, diamond has a, giant structure of covalent bonds. So, due to which it has a higher melting point. So, I would write diamond has a high melting point due to giant structure of covalent bonds. And Diamond has, stronger bonding between all the atoms. Because, because we know that, diamond has a shape something like this, you know. So what is basically happening here is that there are several, carbons, bonded in diamond, something like this, and furthermore. So due to that, there are high number of covalent bonds, which require high amount of energy to break. However, in iodine, there are weak intermolecular forces. Let me tell you that intermolecular forces is a general term, and if I tell you specifically, but you don't require it at this level, the forces between iodine molecules are called ID forces or induced dipole forces, or you could say London dispersion forces. Several names, but IMF or intermolecular forces is a general term. Okay, so here we are writing weak, just to kind of refer that the the IMF existing between iodine is weak. Okay, we are not specifying which force is present. All right. To difference in the electrical conductivities of calcium and iodine. So we know that calcium is a metal and it has, mobile electrons or free electrons. However, iodine has no mobile electrons. Iodine has no mobile electrons. Okay. Partly diamond and graphite are different forms of carbon. Explained in terms of its structure why graphite is a lubricant. So we know that I roughly drew the structure of diamond. It's something like this. Okay, and furthermore, however, structure of graphite is kind of a layered structure. Okay, sorry. No, it has layers. Due to the presence of layers, the graphite layers basically can slip over each other, and due to the presence of layers, the graphite is a lubricant. So we'll write here like that the atoms are arranged in layers. Graphite, due to which, or like these layers can slide over each other. Okay, part C, okay. A compound of sodium, iodine, and oxygen contains this percentage of sodium, iodine, and oxygen by mass. Reduce the empirical form. Okay, let me draw columns for so, iodine, oxygen. All right, firstly, we have to divide the percentage, like each of the percentage of all the individual um, uh, elements with their AR, okay, atomic mass. So for sodium, it would be 11.62 divided by 23. For iodine, it would be 64.14 divided by 127. For oxygen, it would be 24.24 divided by 16. Okay, so it would give us for sodium, the ratio would be 0.505. For iodine, it would be 0.505. And for oxygen, it would be 1.515. And now we'll divide all these ratios with the least ratio. So the least is 0.505, 0.505, and 0.505. This would be 1, 1, and 3. So the answer would be NaIO3. Okay. So this is the end of our paper, and I hope I was able to explain these two questions along with the rest of the paper. Not quite simply, and I hope you were able to understand it, and I hope I made it easy for you. And if you still have any query or any problem, so you can tell me in the comments, and I'll try to resolve it. And till then, have a good time. And please do like, share, and subscribe my channel. Thank you.